Today's aim is a little long. We have a couple of trig questions, and then we're going to talk about angle of elevation and depression, which will go pretty fast once you set it up. Trig functions help you find side length measurements, and inverse trig functions help you find angle measurements. So anytime you're looking for the angle, you're going to want to end up using inverse trig functions. It's just a little reminder. You have this on your homework tonight. So yeah, plenty of practice. Find the missing angle measurements. Little man or second singleton asked, why can't it be big man? It can be big man. He's at X. What is 6 in relationship to big man?
Why can't it be big woman?
It could be big woman. 6 is opposite. 15 is adjacent. It could be big bear if we wanted it to be. Big squirrel. But it looks like a person, so. All right, opposite and adjacent. What am I using? Tangent. Good. Tangent of my angle measurement is the thing that I don't know, so X is equal to, what's the ratio for tangent? Opposite over adjacent. So opposite side is 6 over adjacent side is 15. If you don't know your trig ratios, SOHCAHTOA, I would learn those very fast. From here, and commit them to memory for the rest of the year because you'll be using it for the rest of the year. From here, how do I get X by itself? What do we call that? So we're not multiplying by anything. We're going to apply a function to both sides. What function is that? Do what? The inverse tangent. So tangent inverse to both sides. It's a function that we're applying. We're not multiplying. So tangent inverse of the left side, tangent of X, equals tangent inverse of the right side, 6 over 15. Tangent inverse of tangent of X is going to undo that tangent. So tangent inverse undoes tangent, and we're left with X equals. And then what's on the right side is what we'll type into our calculator. So we'll need tangent inverse of 6 over 15. And I'll call on someone random to tell me what that is. Gavin, you're lucky number 1. If you'll tell me what you get when you get it. You okay? Do I need to look at it? I can't promise I can help with that thing, but I could try. You what? Let's look. Oh, that's good. Okay. Oh, yeah, that's fine. Degrees is good. That's what we want. Let's do 22. What do we think? 21 or 22? 22. 22 what? Good. Awesome. All right. Try the next one on your own. I'll give you about a minute and a half. Try it on your own. You have an A and an H. I see lots of good things happening. Big man is at angle B or X. 35, I know a lot of us label these correctly, so hypotenuse, and 26 is adjacent. And remember, cosine is the one you want to use for adjacent and hypotenuse. Cosine of X is equal to adjacent is 26 over hypotenuse is 35. And then we're going to take cosine inverse of both sides. So cosine inverse of cosine of X equals cosine inverse of 26 over 35. Remember to get cosine inverse in your calculator. You want to go second cosine. If you're not trying these in your calculator and you come to me on a test and you're like, Miss B, I don't know how to put this in my calculator, I'm going to say I hate that for you. You got to be practicing with me to learn how to do this. If you need a calculator, you can always borrow one from me, or you can just Google TI-84 online and it will bring one up for you. From here, X is 42 degrees. Who got that right on their own? Raise your hand. Good. All right, now we got to talk about angles of elevation and depression. What's elevation mean? Up. What's depression mean? Down. So remember that when we're doing these. An angle of elevation, an angle of depression are alternate interior angles. So what we do is we make a horizontal line on the top of whatever object is at the top. Right here, it's a hot air balloon. We do a horizontal line on the top, and then the person on the ground creates a horizontal line on the ground, and then your angle of elevation from their line of sight to the hot air balloon, this is the transversal. And so 38 degrees, your angle of depression is the same as your angle of elevation from the person. So we call it an angle of elevation if you were creating an angle from a horizontal line upward. And then we call it a angle of depression if you're creating an angle from a horizontal line downward. Okay, that can be a little confusing, but once you start sketching pictures, it'll get a little bit better. Since they're alternate interior angles, that means that they're going to be congruent every time, and that's going to be super important for us. Flip it when you're ready. So we see that we have a horizontal line on top of the statue's head, and then we have a horizontal line where the person is looking, and then we have a horizontal line on the ground where the feet and the bottom of the statue are, and we just have to classify each of these as angle of elevation or angle of depression. So let's say angles of elevation. And tell me an angle in our picture that's created from a horizontal line and then going upward. Nope, that's a horizontal line looking downward. So notice like 6 would be here. That makes it an angle of depression. 8 is from this horizontal line in the middle downward. So that's an angle of depression as well. 9 is an angle of elevation because you're going from the bottom up. So angle 9. Angle 9. And then 7 is going from the line of sight looking up at the statue. So 7 as well. So angle 7. That makes our angles of depression. 6 is going from the top of the statue's head down towards the person, like the statue's looking at the person or the line of sight. And so that would be angle 6. And then angle 8 is going from the person's straight on view from their eyes downward to the statue's feet. And so that would be angle 8 as well. It can be a little tricky to classify these, but once you get the hang of it, it'll be pretty okay. From an airplane at an altitude of 1,200 meters, the angle of depression to the airport is 28 degrees. Find the distance from the airplane to the airport, and it's going to be your diagonal distance. So we got an airplane. Let's draw an airplane. You might feel silly drawing these pictures, but that's the only way to get through these problems. I promise you. You can't do these problems without drawing a picture. So we got a little airplane. Mine kind of looks like a bumblebee. It's fine. Got a little airplane. My airplane's going to the left. Little propellers on the front. It's my little airplane. And it says it's at an altitude. What's altitude? The height above sea level. So our altitude is actually... So our horizontal line is going across. Altitude is actually from sea level or from the ground. And so here's the ground. And our altitude would be on the left side. This is 1,200 meters. And then we got an airport. Where's the airport? At the bottom. On the left or the right? Right. On the right. This is your little airport. Airport. And it says the angle of depression to the airport. So we're actually creating an invisible line from the airplane to the airport. The angle of depression means you're going to start at a horizontal line and go downward. So we're going to start at the horizontal line from the top and go downward to create that 28 degree angle. If it said angle of elevation from the airport, then you would start it from the ground and it would go to this diagonal line because it would be an angle of elevation. They want to know the distance from the airplane to the airport, so X. I only know 1,200 meters here, and X is my what? Hypotenuse. Yeah, this is a right angle. And so X is my hypotenuse, but I don't have anything else in this triangle to help me. This is where alternate interior angles comes in. Your horizontal line where the airplane is and the ground are your two parallel lines. Your diagonal is your transversal, and so 28 degrees would also be your angle of elevation here. That can help us because to solve this problem, we're only going to be looking at this triangle down here. And the angle measurement that we know is at the airport, and so big man's going to go at the airport. That's where our angle measurement of 28 is. What is 1200 in relationship to the airport? Opposite. So what could I use to find the diagonal distance? Sine, good. So sine of my angle measurement, 28, is equal to, what's your ratio for sine? Opposite over hypotenuse. Opposite is 1200 over hypotenuse is x. And how do I solve that for x? Multiply both sides by x. So I have x times sine of 28 is equal to 1200. Well, then what? Divide each side by sine of 28. So x is equal to, and I'm going to choose one more lucky person to tell us what this is. $25. Lillian. Thank you. Oh wait, we're not taking sine inverse, right? It's just 1200 divided by sine of 28. You're just typing this part in. Good. Yep. Okay, big number. 2,556.06 what? 5? And what are my units? Close. Meters. The fact that it's a word problem was a big red flag of like, oh man, I need units on this. If it's a word problem, you definitely need to put units. So the airplane is 2,556.065 meters away from the airport. What questions do we have on this? So tomorrow we're going to do 2 examples where we're finding all of the measurements. So notice on the first triangle, we'll have 2 sides to find, 1 angle to find. On the second triangle, we have 1 side and 2 angles to find. So we're going to be finding all the angle measurements there and all the side measurements there. And then we have 1 more angle of elevation problem or angle of depression problem to do tomorrow. That's going to be before our test. And then you'll have a quick 3-minute test tomorrow. Those problems on your homework that are like, pick the best method and keep going, like pick the best method and find whatever it wants you to find. That's an emphasis for this week. Notice it's been littered all over your homework. So make sure we know how to do those. Make sure we know when to use which method. And let me know if you have any questions or if you need any help. Yeah?